race just like that. So what it is basically quite simply, imagine you're trying to repair a boat. Normally when you're working with boxes, you have to be very careful on the way you weight your resin, you measure your resin. So this is an easy thing. When you're in a workshop, if you're in a boat moving, it's less easy. So the idea was, first of all, try to find an easy way for people not to make mistakes when they mix the resin and hardener, but also find a system that could be working as fast as possible. And it's quite strange when you go for a Volvo ocean race, basically go all around the world during 9 months. So you're gonna have 30 degrees, but also 2 degrees. If you go to Cape Horn, you probably have some snow, and then you will go up on the Atijaya in Brazil, and you probably have 28, 30 degrees with 95% humidity, and which is not really good for laminating. So as Grizzletech, we were approached by Composite Patch to make such a resin. So we've been formulating a resin for Composite Patch, and that resin is quite special because it is really not sensitive to water. Even more than that, you can even harden underwater, which is quite practical. What you have is you have the resin and the hardener. They're pre-dosed, and they're separated just by a little plastic ruler. So we'll be opening one afterwards. So all you do is you basically take this off, mix it. There's a color coding to make sure that once it's well mixed, the color changes, and then you just apply it on the plastic. So basically, Composite Patch was created by people from the composite industry, from actually people who are in the racing world, and they were trying to find a system for themselves. That was the whole start of the thing. What's interesting is that this system has been used, is being used right now, for example, on the Vendée Globe race. On the Vendée Globe race, out of the 10 first ones, none of them are using this. So this has pretty much become a standard for the race. But you don't live only from the race. And what's interesting is this is not being used not only in the race world, in the sailboat race world, but it's starting to find other uses that are really interesting. There are other people, like sailors, that need to repair outside. It's wind blades. Wind blades are composite. Wind blades need to be repaired. Mostly, they repair them normally when it's good weather, because resins supposedly should not work with more than 70% humidity. So suddenly you give them a simple system, and it's quite amazing to see that one system that was born for the racing world is actually going to grow much bigger in the general industry than in the boating business. So in 2010, when it started, there was only one team, the Telefonica team, who used it, and it was quite interesting because, okay, it was invented, but nobody had really tested it in real conditions. And on the first leg of the race to Cape Town, actually they broke one bulkhead, front bulkhead. So what's interesting, the boat captain went to the patch to the front, and he came back 15-20 minutes later, and the skipper said, okay, so how are we going to repair that? I said, no, it's repaired. And it's taken under 20 minutes. So, but of course, on the radio, of course, there was a bit of a mess with the builder, was the designer of the boat, because it's not normal to see a bulkhead break on the first leg. So there was somebody sent by Juan Yulian, the designer of the boat. There was somebody sent from King Marine, the builder, and then there was the judge. The judge, the guy with the ultrasounds, making an inspection. And he came, he made an inspection, and the guys at King Marine was everything, we'll make a small oven to pure repair. And the person who did the inspection said, actually, you're not going to do it any better than that. So why would you even take the repair out? So that repair actually continued with the rest of the world. So it's really interesting because all the teams learned about that. But Composite Patch had a deal with it's a Spanish company, had a deal with a Spanish team. The Spanish team said, hey, please give us a competitive edge. So please, we'll take it aboard, but don't sell it to other teams. Which happens. So this is what happened, and they were really happy with it. So what's really interesting is that afterwards on the Vendée Globe heard about it, because there's so many people over the racing world that go with teams. And in France, Michel Desjoyaux, who's pretty much a hero, heard about it, tested it, and now all these boats are using it. So this is how it went from the Vendée Globe from the Volvo race to the Vendée Globe, and then it came back to the Volvo race last year, well, the last edition. And it was interesting because actually the 3 shipyards that were involved in construction all decided that this was really the best system that they could take on board. So it was selected as the only on-board repair system for all the boats. So, we have a big thank you to say to Nick Weiss of the Volvo race, because he trusted our system. And what's interesting is we went to Lisboa at the end of the race to ask all the skippers and all the boat captains, okay, anything we could change, anything we could improve. And all of them are extremely happy with it. They don't want us to change anything about it. And on the contrary, they're taking, because most of these guys have jobs outside chartering or whatever, and they will take them with them. So we can find lots of Composite Patch that came to the Volvo engines and left. Now 2015 has been selected by one of the big manufacturers of blades, La Mesa, as an official repair system. So now basically any blade around the world is being repaired with that. In 2016, well, because now we work with the blade industry, they asked us to pass the ISO 9001, so that is done, and there's even Airbus that approached us because they find it as a possible way of repair. So it's actually been selected as one of the 3 products that maybe in the future, because anything in the aerospace industry takes other certifications and everything, but it's being looked at by Airbus to actually do repairs also. And the main reason is you don't make any mistakes. I mean, if you guys work in the composite world, you know that most of the mistakes in working with epoxies is you make a mistake on the mixing ratio. And if you've never made a mistake with the mixing ratio, it probably means you've never worked. Because everybody's done it. Especially if you have to work outside. Then you have a scale, you're trying to weight products, the scale is moving, you adjust more or less what it is. Here it's all pre-dosed, so you can't make a mistake. So fiber-wise, the patch is supplied in a very simple format. It's actually emergency orange tube, and you have your patch inside with instructions, very simple, visible instructions. Also, the main question is in how long does it harden? So it could, depending on temperature, in how long it will harden. And actually, even as people won't know what temperature it is, there's even a sticker with a thermal sticker on the patch, so you know what is your temperature. So you can actually take it off, stick it on your repair, and you actually know what is the temperature of your repair. So it's a little trick, but it's actually quite nice when you're repairing on a boat, so you actually know what to do. The fiber we use are typical fibers used in boat building. So Biax 600, which is the most sold, UDs, triaxials, quadriaxials, just nothing special. Same in glass and same in carbon. In carbon, most of the boats at the end they take UD and biaxial, because with that you can do pretty much everything. So the idea is also some. Okay, on a Volvo race, for example, the boat captain will be a competent guy. He will be someone who knows how to repair. But when you go to the Vendée Globe, for example, there's great sailors, which does not mean they know really well how to repair. Probably not. So mainly, if you try to give them a system, they cannot make a mistake. It's just so simple, you cannot make a mistake. Whatever you try to do, you'll get it right. That was the whole point of Patch. You can work in climates, in sub-zero conditions also. Actually, when I tested it for the Volvo, for the first Volvo, they asked, but will it harden at 0 degrees? And we said yes. And I said, at negative temperatures, we don't know, we never tried. So they actually cracked the patch and put it in the freezer for the night. It spent the night at -18, and the next day was cured. So they said, okay. But the funniest part is at the end, the reason why they selected it was also they took their normal composite box, weighted it, okay, weighs 7 kilos. 7 kilos, with these 7 kilos I can repair that many square meters. And then they took this, they weighted it, and they realized with the same weight they can repair nearly double. Because you don't have brushes, acetones, just scales, pots, mixing pots, everything. But at the end it was interesting that the very first one that was used was also a matter of weight. It's a very light system. application, it will obtain 90% of the mechanical properties. So it's actually pretty good. So fibers, we look at that. Most of the fibers are bidirectional. We also have a twill. It's pretty much anything. I don't think normally, nobody else would use different fibers than that. So that is pretty much covered. What's interesting is this also went. There's two types of customers in the marine industry for the patches. For the boat owner who's got his boat in the dock and just going a little bit left on Sundays and a little bit right on Saturdays, they don't really use that. Most people that will use these patches are people who are traveling with boats. So in the community of people traveling with boats and crossing oceans, basically, then people get more serious. If you're just a weekend boater, normally you just ask someone to do a repair for you and just come back to port and that's it. But mainly when people start crossing oceans, then they start to think on how to repair. So we have many customers buying these patches. This guy, for example, was a customer who arrived in New York on a catamaran, and he had a small problem. He had only one engine. And a catamaran with one engine is not really nice. And when you try to dock it in the river, and you're not used to docking the river with its currents, he ended up putting his catamaran against anchors. And he actually did 5 holes at the side of his boat while docking. A bit embarrassing. But what's interesting is this guy has some patches, and you see, like the typical, that's what he had, and he fixed them. He fixed them all. But what's even better is it's a Bassa boat, so he didn't want any water to get in. And he was really happy because within 45 minutes he had arrived at the port. It was starting to rain, so he said, you know what, I'm going to repair right now. In 45 minutes he had fixed 5 holes in the hull. You can't really beat that. So this type of customer is really very happy. But then you also have a completely different type of repairs. You see a lady, she's not really a racer for the Volvo race. She is, luckily she's in Tahiti right now. It's a couple who was traveling on a boat, and they went to an atoll and missed the entry pass, so they actually went on a big coral reef. And they didn't really make a hole in the boat. They just basically shattered the whole key line. So they were quite worried. The interesting bit of the composite patches, it is not sensitive to water. It will harden underwater. So you actually can do underwater repairs. I would not consider it's a good emergency repair underwater, because repairs underwater are not easy. It's not very easy. So if your boat has got a hole that big, it's probably sinking. The time for you, if you haven't tried before, if you haven't trained before, it'd probably be a better idea to have a piece of plywood and 4 screws and just try to screw it from inside with some Sikaflex or something like that. But if you have some time, you can repair with this in the water. The big challenge with repairs in the water is this will harden in the water, but how do you stick to the hull? Well, first of all, it's like any composite thing. If you have not prepared your surface, if you're algae, it will not work. If you're on your anti-fouling, it will be as good as the anti-fouling is sticking to the hull. So you basically have to remove the anti-fouling, but once that is done, you also need to remove the film of water that is between the hull and the patch. And to do that, we're using an epoxy adhesive. This is quite nice also because this is an epoxy adhesive that will also harden the water. And so it's a component sub-cartridges inside, but the nice thing is use a normal gun, use a normal coking gun. Everybody's got a coking gun like that. Normally epoxy adhesive cartridges are typical 400 milliliters with a double gun that nobody has except in a shipyard. This, anybody has it on their boat. So what you do is you actually, this is what she's doing here. See, she's putting adhesive on the patch. She's puncturing the patch with adhesive, and this you will put it under water, and you will press from the center to the side, and that will remove the film of water. What's amazing is, these people are like 60-something years old, and they actually put 26 patches in the water. So it's pretty impressive. So it's kind of like, and I like the picture because it's kind of a picture that if she can make it, probably anybody can make it. So see, she's preparing the patches and then passing them to her husband into the water, and he's just putting his patches. What's interesting is that initially they thought we're going to make a temporary repair, So we can go to Tapete, and in Tapete we'll be able to get the boat out of the water and make an all-permanent repair. I've been following them on their blog, and at the end, it looks like they've never taken the boat out of the water. They're really happy with the repair, and so far so good. And they keep sailing. So I'll show you a small video of. Small video of repairs to be done in the water. Tips that we recommend anybody who's using it. Let's go faster with that. So basically, you just mix your resin and hardener until the color is homogeneous. So remove the first clip. Then remove the origin clip. Remove the clip, and then you just press the resin onto the patch. So the resin has got very good wetting properties, so you can see it's wetting the garment right away. Then after opening it, you just use the static mixer on the adhesive and basically put some adhesive. Normally it's good to remove the first 2 centimeters of the static mixer, because probably it will not be very mixed the first 2 centimeters whenever it comes out. And then basically simply put adhesive on the patch. You see the adhesive is very isotropic. It's got the consistency of a mechanical grease. So low viscosity but very high isotropic, which makes it nice because you can really apply it for bulkheads or anything, but also here you want one side. And applying the adhesive, and then you just butter it all over the patch. So apply a thin layer everywhere. And this layer, apart from being a good adhesive, is the one that will really help you to remove the water which will film between the hull and the patch. So here we filmed it in an aquarium. Basically you position the patch wherever you want to put it, and from the middle, you take the spatula and you just squeegee it out. So that is not something you want to be doing in an emergency situation, but it's a good thing to repair this. You'll see on the other side. See, most of the adhesive is actually removed, but that's a good thing because it's actually pushing the water in front of it. See, on the other side, it does. You can see it's completely removing the film of water. So that's what you're supposed to do. The nice thing with this type of